Hey, what's going on, folks? It's Mike here, and today I'm very excited to be bringing you this conversation with founder, software engineer, and writer of the Game Engine Black Book series, Fabien Sanglard. In this conversation, you're going to hear us talk about everything from programming, education, his startup company, and his process for writing the Game Engine Black Book series, and more recently, the CP System book. You can find lots of excellent resources on Fabien Sanglard's website, as well as his books, and I hope you go ahead and enjoy this conversation. First and foremost, I just want to thank you for your time, taking your evening here with me to talk about some fun stuff, some stuff that I think we're both involved with and admire in the programming world. Um, and I want to sort of tell you a little story first as we get started, because I've been familiar with your work. I
hmm
think we sort of crossed paths on a YouTube comment I saw. I was talking about the Doom guy, and but I've actually been familiar with your website for quite some time. And I've been using your article about the Doom fire effect in my C++ programming class for about 2 years now. So I want to just thank you for writing that brilliant
Also,
article.
you're a teacher. I thought you been assigned it as a student. Nice. That's really cool.
Yeah,
How what kind of a reception have you been getting from students with this assignment?
very good. Because, with a lot of these old school graphics effects, and the way I teach programming is very visually. I tell them we're programming one pixel at a time, which is exactly a Doom fire effect, how it fits.
hmm
So I think students, and myself, this was true, and I'm going to be curious about you as well. Learning by programming computer graphics is very stimulating. I think it's very rewarding when you get something working. It
hmm
also helps with the debugging process as well, because again, you can see what's going on. So
Exactly. I agree. Yeah,
yeah.
it's instantly rewarding. It's also instantly frustrating. If you're working with a GPU and you're staring at the blank screen and all you can do is GL clear,
Hmm.
that can be a bit frustrating. But yeah, pushing pixel by software, definitely a good idea for student. I agree 100%.
So, we're gonna kind of wind back a little bit here and talk about some of your programming experience. But have you always been interested in computer graphics? I know you've done a range of work throughout your career, but in particular, I've noticed a lot of computer graphics work in gaming and effects, virtual reality. So, was that an initial draw to computer science for you?
Yes, always. My very first program actually was a graphic program. I know you want to dwell a little bit more into it later, but um, right at school, the first program I write was a logo program. I don't know if you're familiar with those.
Hmm.
Essentially, you have like a cursor that you can put down on a piece of paper, you move, and you can turn. So my very first program, I drew a circle. So right from the beginning, I was always into computer graphics. And I think if you lived through the 90s, you could not uh, be oblivious of how interesting graphics were. Like every year we were getting a new graphic card, which was twice as powerful as the previous one. So it was fascinating to just be in the middle of that. And there were at first there were not many books for it, but then a lot of literature started to be issued for it. So I wouldn't say it was easy, but it was definitely very interesting. Much more so, I would say the audio field, which was
Mm.
almost solved problem once Sound Blaster came up with digitalized playback. At first, we could only have sound effect, but pretty soon we had like whole music with like very high accuracy. Graphics was really the thing, the problem to solve, and still is to some extent nowadays.
Hmm. Yeah, so with that first program, you said that was in Logo, that you're
Mm.
programming. Was this with like Turtle graphics as far as the or some other API, or were you
Yeah,
just
the turtle.
plotting? Yeah.
Yeah, turtle. Yeah, exactly. You know your stuff. That was in 1985. I was 8 years old.
Oh.
And there was a French politician who decided that every kid should learn how to program. So he had this like huge program, 11 million kids in France got to program. And so they sent a PC in every school. There was one PC and 10 Thomson MO5 terminals. And like the teacher will come with like an 8-inch floppy disk, which back then looked like it was a painting, and he would load that, and we would all get access to the tutorial in Logo, and we could program whatever we wanted.
Wow, that's pretty cool. Is that program or those types of programs still going on in France or other places where they're
No,
pushing?
so weirdly, the program was abandoned a few years later. I think the teacher didn't have much training, and my little brother, who is like 4 years younger, did not get access to it. So by the time 4 years later, it had been abandoned, unfortunately.
Wow. Okay. I mean, obviously we might have a bias here, but teaching everyone how to program, I think, is incredibly important. So, um,
Yeah, especially nowadays. I mean, back in '85, I think it was kind of a gamble,
mhm.
but no, it's like it's a no-brainer. It's everything. We carry a computer in our pocket everywhere we go. Um, my little niece, for her 10 years old anniversary, she got a cell phone. So it's really everywhere now.
Mhm. Yeah. So after that first programming experience, drawing your first circle, I mean, were you hooked at that point and just kind of trying to learn more and more,
Oh
or
yeah,
was it something? Yeah.
it was so interesting. I've always wanted to understand how things work under the hood. So actually, I have a little anecdote about that. If you program in Logo and you write a small program where like push down, move one, go back one, turn right one, and you repeat that 360 times, you expect a full circle on screen.
Mhm.
But once I ran this program, I noticed there were holes in it. And that's why, as a teacher, I was like, what's going on? Like, is there an issue with my program? Like, why is the circle not full? And back then, the teacher could not explain to me what aliasing was. And so that I've always had those questions about how does it work? How does the compiler ever? I mean, I didn't know what the compiler was, but like, how does my text become instruction for the CPU? So yeah, always been super interested in knowing how things happens at a lower level. I think that's one of the things that helped me the most as a computer programmer, is that never limit myself to knowing what happens at my level. Like if you're programming C or C++, you have system calls underneath you, and then there's a kernel and stuff like that. And the same goes if you program in Java or in Python. You are in an interpreter or in a VM, things happen. So served me well over the years to always be curious and see what happens once I sent a request, how it's being fulfilled.
Do you think there's something lost when programmers, have to, if they're working at too high of a level versus if they maybe first start off with literally plotting pixel by pixel and like you found this discovery of, oh my gosh, why isn't it a nice circle? How do I effectively implement anti-aliasing or these types of things? Do you think that's maybe the right place to start, as sort of low level or pure as possible?
It's probably, well, it's definitely easier to start at low level and then go up
Mhm.
and get more abstraction and improve your velocity in terms of programming. The opposite is probably harder. And
Mm.
maybe I wouldn't even say it's needed. Like, so back in the 90s or in the 2000s when we were programming, the results that was expected from a program was of lesser quality than it is nowadays.
Mm.
I think if you have a project and you jump onto something, people expect a lot of you because you have a lot of libraries, a
Mhm.
lot of things, and because you need to have a certain velocity when you program and you produce a product, and you not necessarily have the time to go deep. And that's the main problem I think programmers nowadays face, is that they need to get going
Mhm.
and they don't always have the time to really polish things.
Mhm. Do you have any suggestions on maybe somebody who's working as a software engineer now who has to balance that struggle of, well, there's sort of a right way to do things, maybe from the foundations that'll save us time versus, just go, go, go because we have to finish a project. How do you manage that?
I think I think as a programmer, it's impossible to push back and be like, I need more time.
Mhm.
If you do that, I would say, depending on your environment, if you do that, likely they're going to find somebody who's going to go faster. I would say so. If you're frustrated with the quality of the software people around you are making you produce, I would say find a better place, maybe.
Yeah. So let's kind of before we get into the software engineering world, take us, let's see, in 1985, you're writing your first software, and then you're slowly graduating. You're hooked at this point in writing software. What's sort of the next big leap for you? Do you move to a different programming language? Do you start getting inspired by maybe some of what's going on in the gaming world in the 90s? What do you remember next?
I remember using a lot of programs. So the main program after that, the main problem is get access to a compiler.
Hmm.
That's something maybe the younger generation are not aware of, but a compiler was several $1,000s, so you couldn't get it. And even if you got your hand on it, it was gonna be no manual, or like it was under the desk floppy disk. So I would say for a while, I did not program anymore because I did not get access to the stuff. I would say it's when I became a teenager, I got access to Boron C and C++,
Mm-hmm.
and that I managed to program again. And it was fun, but it was always frustrating. In France, we didn't have access again to a lot of literature. I know that in USA, you could get access to Michael Abrash article in Dr. Double. We didn't get much of that in France. And also PC was not very developed. The scene was mostly for Atari and Amiga. So yeah, I remember it being difficult to get access to what I needed.
So did you have to wait till university or other schooling by the time you get
Yeah,
a compiler?
university is when things were really started to take off. Not only I had access to like a big Unix server with like GCC and everything, but I was surrounded by people who liked the same thing I liked.
Mm.
Back when I was living in my little town in France, very few people were super into programming computers. And actually, a lot of things I liked. For example, I liked Dungeon and Dragon, and I had really a hard time I had to like coerce my brother into playing with me. It was it was really at university where I got the materials and the environment of people really who were super impressive because you're not necessarily challenged when you're just doing things by yourself, but once you meet other people who have like different interests, that's when things really can take off. That's at university when I met people who knew to write a breakcaster.
Mm.
I had no idea to do like orthogonal or projective projection, stuff like that back in the days. That's where I met people who could actually I could actually work with.
Were these people some people that you would work with later on that you or did they kind of go to different companies um and they
No, like pretty much everybody who I went to university with in France, they are still in France.
Mhm. Got it. Okay. So throughout your university time, then were you then able to take some computer graphics courses where they were teaching things like I guess at this point maybe OpenGL? Were there SGI machines at that point, or all just
No,
from scratch?
no. Yeah, so we had no hardware accelerated stuff. So it was mostly system programming. Again, it was early 2000, late 90s, and like all the computer graphics stuff was not developed. I heard that in University of Utah, they had a really early program and that was really cool. But as far as getting an education for it in France, it was hard. Actually, even getting into computer science was weird in France because if you wanted to become a programmer, they recommended that you would do a bachelor of mathematics,
Hmm.
with just like 2 or 3 hours of programming on the side. So yeah, it was really far from it.
Hmm. Would you recommend, well, as a graphics programmer, one of the things I see in my students that can kind of separate them from others is having the mathematical skills. Would you recommend students who do want to, say, particularly study computer graphics, go that route and do a lot of the mathematics, or is it you just need both? And
I don't think you need a lot of math to be. I mean, you're better suited to answer this question. But my vision, having written a 3D engine, is that you need good trigonometry skills. You definitely need to understand cosinus, sinus, and like matrix multiplications. But I don't think you need much more than that. I don't know. Maybe things have changed, because the last time I programmed a 3D engine was 2012. So, I mean, it's been 10 years. So I don't know. Maybe things have changed, but back in the days, I don't think it was very much necessary.
The 2012, which 3D engine or project were you working on at this point?
Oh, I was working on a shoot 'em up 3D engine on the iPhone. So I jumped on the iPhone wagon pretty early, and one of my favorite all-time video game is Ikaruga by Treasure. And one of the aspects that always fascinated me is that they move from 3D to something that looks like 2D. I don't know if you've seen the game. So in 3D, the camera moves around the ship, and then as soon as the gameplay starts, it moves from above, and it's like you're on a 2D grid. And I was like, wow, this is super cool. How do they do that? Like, do they switch from perspective projection to orthogonal at some point, and it's just like it's seamless? The answer is no. Is that they just map the camera to the ship, and they do it at a distance such that there is no so much perspective divid that makes that distort the ships, right? So doing that for iOS in 2009, they were not 3D engine, and they were not 3D engine capable of reaching 60 frames per second. So, and also I had just read Master of Doom, and I was like, I really want to write my own 3D engine in C, and I did it, and it was super interesting. I've learned a lot.
Very cool, very cool. But that's something I want to touch on. In fact, just as a little precursor for anybody who's going to watch this later, I have my copies of books with me here, which I'm very grateful for that you've written.
Thank you. Thank you for buying it.
Of course, it was something, and we'll talk more about I'll be curious about the book writing process, but it was something, as soon as I saw it, I said, I have to have this, and I have to read it, because what a treasure to have some of these resources, and it's put together with a lot of care, which again is why you have folks like me finding your website and really enjoying
I really tried to put my heart into it. It was it was a very important project for me. It was a big part of my teenage years, and I really wanted to preserve it, and I wanted people to be able to understand the thing as a whole. Because if you only get the source code, you don't really necessarily understand what a 486 CPU is, or what a cache line is, and stuff like that, and all the work it takes to ship a video game. So it's I'm glad that people received it well.
Yeah, and while we're sort of on this, I'll sort of loosely put this together. So we've been talking about the Doom Black Book here, which is about a C-based game engine. You wrote a C-based game engine for iOS for performance. And then you also started this company that I wonder if it's inspired by C. It's called Memset Software.
Oh, absolutely. Absolutely. Yeah.
So tell me just a little bit about that. I know we're skipping through your kind of finishing university. You're working in Paris and then Toronto, if I recall, and then
Toronto. Perfect. Yeah, exactly.
And
I think it's anybody's immigrant dream to, when you move to a country, you start by working from somebody. And I think pretty much everybody is like, oh, I kind of would like to run my own show, have my own thing. And then as soon as I became a permanent resident and I was legally allowed to, I did it. And it was right when programming apps was all the rage. So I became a contractor and I started Memset Software. Originally, I wanted to call it, I think I wanted to call it Malloc, but the name was taken. And and I just like, Memset was cool. So it's a cool name. So I published my video games under this company's name. Yeah.
Very cool. So was this mostly gaming projects and then contracting for others, or was this all sort of an operation? What kind of projects were you
It
working
was
on?
a one-man operation. I was the contractor, and then it was important for me to have a name. So I wrote, video games. I wrote Fluid, which was a water simulation. Originally, just something I wanted to. So when I started the company, I'm like, I'm going to go to interviews. I want to be able to show something that demonstrate that I know how the platform works and I know how to do it. So I wrote. Back in the days, I wrote a demo which was simulating water effect. We've all done that. It's like a high match situation and you propagate. And I always told myself, if there is ever a touchscreen device, I should write a water effect. That would be really cool. And then iOS, the iPhone one came out. I'm like, okay, that's it. I need to write something like that and put it on the App Store. And I put it for free. And that's what I wanted to do. I just wanted to go to interviews. And that thing went viral. And that became the #1 App Store app in June 2009 worldwide. It was like downloaded 15 million times. It was crazy.
Wow.
It was really cool.
Is this something we can still find on the iPhone App Store now if we search Fluid
It's
and
still there.
Memset
It's
software?
still there. You have videos around. I have not updated it in a long time. And because Apple, they break the backward compatibility quite often. I'm not sure it's going to run, but you can give it a shot. Yes.
Great. And you're, with MSET software, are you writing this software in C primarily, with an interface into, I guess, Objective-C at the time, or?
Yes. So there is a little anecdote about that. Is originally I wrote everything in Objective-C because I thought that's all iOS could support. And then John Carmack released the source code of Wolfenstein 3 for iOS, and like, holy snap! They wrote all that in Objective-C, and I opened the source code, and I'm like, what? You can call C from Objective-C? This opened the door for so many things. So I actually scrapped everything I was writing, and I'm like, that's it. I'm just gonna have the interface in Objective-C, and it's gonna render in a surface, in OpenGL surface in C, and that's how the video games is done too. And that's why I was able to port it to so many platforms. Shmup runs on Android, iOS, Windows, and Mac. Mostly because it's written in C, and mostly because I've learned a lot of my engine design skills at University of ID Software, where there was always a layer of abstraction around. The file system is isolated, like the graphic, the rendering system, sound system, music system, everything is in a module where there is a very strict layering happening in their engines, and that's exactly the way I design mine.
I've always sort of wondered why there isn't more native software development encouraged. Maybe that's my personal background, writing computer graphics and knowing C and some of these languages. Do you think that's something that should be encouraged, or, if students are learning, they should just say, let's just write it in C?
Well, for video games, I think most video game is done in C++. The thing is that it's so annoying to run after heap corruption and Stack Overflow and buffer underrun and stuff like that. I can understand why people don't want to use it. But besides Rust, I'm not sure there is any real-time programming language that does not have a garbage collector that's gonna mess up with your frame rate. So I'm not sure. Like, have you seen game engine and games being written in anything else but C?
Primarily, in all of my professional career, it's been C and C++. There's sometimes some games I've seen in D, there's some in Rust, Java, of course, but yeah, not on the AAA scale usually. Not as frequently, yeah. So I guess that's the answer then. We just have the C++ for games for now.
I think as long as you have a garbage collector, I mean, that's the end of that's the answer. If it has a garbage collector, you won't be able to use it for game for sure.
Yeah.
So maybe Rust will take the cake. I think there are a few languages that are coming up and are trying. I think even game developers are getting frustrated with C++, understandably so. We'll see.
Yeah, we'll see what the, one of the things that I appreciate about C++, and this might just be from its age, so not so much the language, but the tooling ecosystem around it, because it has to be sort of mature, in a sense of we need linters and static analysis tools to prevent, as you said, stack overflows and these types of things. Are there any particular tools? What's your sort of development environment look like? Are you using IDEs,
Oh,
debuggers?
absolutely.
Yeah.
I think, yeah, IDEs are, I mean, I'm very happy with Sea Lion, for example. I think
Mhm.
it's a really good tool. Asana, the address sanitizer, is a super good tool, but I think with C++, my personal stake on that is that we always keep on adding more tools and more tools to try to make it better. And we always hear, oh, with this methodology, we're going to be solving finally the problems. But I think what really the industry is moving toward is Rust. And I think the safety is built from the compiler. It's tedious sometimes, it's annoying sometimes, but I think it's promising.
Mhm.
And also C++, every time there is a new revision, like what's the latest one? C++ 22?
23 right now. It's just been approved. Yeah.
23, they keep on adding more feature. And what I see is that quite often you get in a team and nobody can agree on what set of features you're going to use. So
Mhm.
you get to read the code and it's completely different style. You have people who like meta programming. You have people who love the STD. You have people who love Boost. And it's just like, it's like a box of chocolate. You never know what you're going to get. And I think that actually, I think it's hurting the language.
Mhm. Yeah, too big, too many features at scale can be problematic, as you say. So I guess if you were going to, restart memset software today, what kind of, would you use Rust? Would you try out another language? Because I guess some of these rules are maybe different when you're a one-person team. Um, and say you're doing game
Yes. So
development. Yeah.
I think 10 years ago, like the three main language would have been C++, Java, and Python.
Mhm.
And I think nowadays those three languages have been not deprecated or replaced, but I think I would go with Rust, Go, and Kotlin.
Mhm.
That's the three language that are the most interesting to me. Although Java is doing a really lot of good things, like for example, the way they implemented virtual threads
Mhm.
are super. It's super well done because all the tools still work. For example, whereas if you use Kotlin and especially coroutine, it can be really tedious.
Mhm.
But definitely, I would use a different set of language. As per having a whole company under my shoulders, on my shoulders, probably not. That's something that people may fantasize about, but it's like when you have to take care of billing,
Mhm.
advertising, accounting, all of that on top of programming, it's a lot of pressure.
Mhm.
I would invite anybody to try it so they get a taste of it. But after a few years, I was like, yeah, I think I want to work with people and share responsibilities and stuff like that.
Mhm. Yeah, I think that kind of fits in, one of the themes for, probably we should talk about these guys here, id Software. In fact, I have both the books here. Get in focus.
Mm-hmm.
So I have two of your books here, and they were a smaller, relatively smaller, you could say, tech company at various times. I think when they were writing Doom, there were maybe 7 or 8 main
Mm-hmm.
people on the team.
Yeah.
So so they're kind of an interesting case study I always think of for the quality of work that they were producing. But before we get to some of the anecdotes, um, so you're working on memset software and progressing through your career, and then well, I should see. When does this idea come about to start writing the Game Engine Black Book series?
Oh, it started in 2014. So my dirty secret is that the book I really wanted to write was Doom.
Mhm.
I think what by a certain age, everybody has a book. Everybody's passionate about something, and you can write something. And I felt the book I really had in me was about Doom,
Mhm.
but I really wanted to be good. So I wanted to master the tools and have a practice. So I was like, I'm going to write something about something much smaller. It's going to be very easy. And in 6 months, I will have a book about Wolfenstein. I'm going to write 150 page, publish that as a PDF, and then I get to work on Doom. And that didn't go as planned. What actually happened is that, first of all, I became very, very interested in Wolfenstein. And I wrote much more about it. And I also struggled with the tools.
Mm.
From the beginning, I knew I wanted to open the source code, and I wanted everybody to be able to see how a book is made, and I wanted people to be able to compile the PDF themselves.
Mm.
So I didn't want to use a tool like Adobe or something that makes the creation process easier. Everything is done in text, and it was super frustrating
Mm.
because I would spend the entire evening trying to make a table. And if you make a table in LaTeX, you find out that the lines don't connect. Like at the intersection, there is a gap. So you go online and you spend so much time trying to make the simple things. So I gave up on writing this book 3 times.
Mm.
And it took me a total of 3 years until I published it in 2017.
So, I mean, after you gave up the first time, what made you say, "Hey, I need to keep working on this"?
Mainly stubbornness and pride. I was like, I cannot believe I'm not going to finish that because it's interesting. And I think it's really cool to write about something because it helps you to ensure you understand it well.
Mhm.
And it was really, it was something I really wanted to complete just based on that. I didn't think anybody would ever read it, but I wanted to create something pretty and something cool, and like gather all my knowledge into one volume. So that's mainly what made me go back to it. What made me eventually succeed is that I found out how I was working, and what was being discouraging is that I would spend 4 hours one evening and I would have nothing to show for it.
Mm.
And I was like, okay, this is what is kneecapping me.
Mm.
I spent a lot of time, I see no progress. So what I started doing is that instead of struggling and being very stubborn on a problem, if I could not solve it, I would just draw it or sketch it, take a picture of it, and then import it as a bitmap. And that is, you can do it easily in LaTeX. And from that moment, that's how I actually started to really cruise. And every day, every evening, I will be able to write a page and so on. And I told myself, eventually, I'm going to have a full book full of like patchworks, but I will be so close from the goal. There's no way I give up at that point. So, and that's how I completed it, by giving myself tiny increments.
Is that something that you still adopt in your work today when you find yourself get stuck trying to slowly break down a problem and
Yes,
do tiny
yes.
increments?
If I find out that it's bigger than I can chew, or if I find myself being discouraged, I'm like, okay, I need to break it down. I need to see some progress on a regular basis for sure.
Mm-hmm. It's
Not
great.
everybody's like that. I mean, it worked for me. I'm not sure it would work for other people. Maybe people just want to take things as a whole, and they are very good at delayed gratification. I'm not bad at it, but I'm only good at it to some extent.
Yeah, I think that's a wonderful tool to have in your tool belt now, though, knowing that and having process to finish
Yeah,
something.
know yourself. You have to know yourself. That's the most important thing.
So as you're writing Wolfenstein and putting this together, even though it's a older piece of technology, were you surprised by um, antidotes or things you found in the source code that were particularly clever or interesting engineering by any chance?
Well, I always knew that it must be packed with marvelous things because you have to. I mean, when Wolfenstein 3D came out, it was mind blowing.
Hmm.
It was a shareware, and usually shareware programs were of a little bit of a lesser quality than full-fledged games, but this was not. That was actually way above everything else. The frame rate was astonishing. Like the action was amazing. So I knew they had to do things differently um, to reach that kind of quality. And but I didn't expect the kind of trick, like for example, there's this effect called fizzle fade,
Hmm.
where they plot screens for to transition between skin, and they use a registers shift to accomplish that. And I was like, that's so cool.
Hmm.
And in pretty much every aspect of it, I found something clever. Like for example, like they have a cosinus table, then the sinus table they're actually overlapping to save some memory.
Hmm.
I'm like, okay, that's a cool idea. And like it's the game engine is packed with stuff like that.
That idea with the cosine and sine table, I've recently seen a lot of Nintendo 64 games have even stolen that trick. So I wonder if it's, again, maybe this is something since I learned programming a little bit later on. I didn't learn some of these hacks, but it's interesting to see maybe that evolution and how programmers thought about stuff. Um, Fizzle Fade, as you mentioned, well, if I was going to implement that today, I have plenty of memory. I would just have a screen and then, pick some random pixels versus, register shifts.
But that's the thing. If you were to implement it this way, it would not be as good because they want the transition to be in constant time.
Mhm.
If you use random, like let's say you use a random location, if it's already shifted, you need to use another random. So
Mhm.
potentially you're never going to be able to do the last pixel. What they did with Fizzle Fad is that it's not something they teach you at school. Is that
Mhm.
deterministically they hit every single pixel once.
Mhm.
That's the beauty of it.
Mhm.
It's just so cool.
Yeah, that's amazing. And I'd recommend folks who are um, listening to this later on to check out your website because you've written about the fizzle fade quite elegantly, explaining the algorithm. So, uh,
Thank you.
so um, I'm wondering, is it valuable for someone who's a student? This is a little bit of a rhetorical question, I suppose, but to actually go and look back at games or software that are, quote unquote old, right? Are students still able to learn stuff about, certainly some of these algorithms and tricks, but what about the hardware? Because that's changed. Is it going to be useful for someone listening to this to go learn about, hey, what was the hardware like in the 90s and so on?
There is really very little in terms of hardware, even in terms of software. What's very valuable and will probably be valuable and essential forever is the spirit. I think back in the days, they had whatever they had and they did what they could with it. And nowadays, the same story. It's always been the same story. You are faced with a certain amount of resource and you try to make the best out of it. So what you may find in those books, I would say, is inspiration. People have done it by the past, and now you're in front of your computer, and maybe, I don't know, maybe you love programming, maybe you don't, but you're certainly trying to get somewhere. And in order to do that, you need to have faith. And they had it, and this is the kind of result you get when you have faith, when you have discipline, and like in every endeavor, when you have a little bit of luck. That's what could happen. So yes, I do think students should read this book. Don't buy it if you don't want to. Read the PDF. But that's also what I got from writing it. I found a lot of cool stuff, but I was deeply inspired by what they accomplished.
Well, I think you're being quite humble. I would encourage anybody to buy a copy of this book. I think it's well worth every penny spent.
Thank you. So I
You're
can
being
stop eating
very
ramen.
humble. Yeah. I'll do the commercial because I'm happy to.
Please.
I've just gotten plenty out of it. But were you surprised? I mean, this book, one, it's kind of it's one of a kind in a way that when I think about books like this, the only book I thought of before this was Michael Abrash's, Programming
Mhm.
Black Book.
Mm.
And that's, 20 years roughly before. Are you surprised that there aren't more texts like this? Do we need more?
Oh
What?
yeah,
Yeah.
like yeah, I'm surprised nobody is writing more about super technical stuff. The thing is that, okay, I think people who are in charge, people who are publishers, thinks it's not going to sell well, and maybe they're right.
Mhm.
I don't know. But I always think of there was a book about the Super Nintendo that was published 5 or 6 years ago,
Mhm.
and I was eagerly reading this book because I love this console and I wanted to understand how it worked. And when it came out, it was a beautiful book, but it was not super deeply technical. For example, I wanted to learn about Mod 7. I wanted to learn about raster effect and stuff like that. And I actually ran into the author of this book, and I was like, "Man, you know how that stuff works. How come it's not in your book?" And he said, "Yeah, the publisher thought it was not interesting, so we cut it out."
Mm.
So I think it's an obstacle, first of all, if publishers don't believe in it. And very few people, I think, really want to self-publish.
Mm.
It's a lot of work. That's what I've done. So that were the two things I really wanted with my book. I wanted it to be open source so people could look into it. And I wanted to write whatever I wanted in it. I didn't want people to come and be like, oh, this drawing is too big. This is boring. I'm like, no, I write whatever I want. And it's going to be just as crappy as I want it to be. And so I would say, yeah, it's a shame that there are not more of them, but I don't think the environment is really helping out.
Mm-hmm.
There are a few. Actually, the latest one I got. Did you read this one?
Let's see, which is it?
It's about Mega Drive programming.
Oh, no, I haven't.
And it's legend of big game development. So it's about the Mega Drive / Genesis. This one is actually very technical. It really explains things at a deep technical level. But it's one of the few, I would say. And I don't know. I mean, part of myself would be like, I was hoping that if people read the Game Engine Black Book or the Book of CP System, they're gonna be like, oh, I have my own knowledge about this area. I could write about it, and that's so why I publish the source code, so people can just take the framework and they can hit compile, and then we'll have something. But I think it takes a lot of work.
Mm.
It takes a lot of work, and you're not gonna get rich writing books. That's the other thing. So it's I wouldn't say it's thankless because you get to connect with a lot of people, and that's priceless. But it's not rewarding in the normal sense people think.
Mm-hmm. Yeah. Well, so you went on to write and help fill the space with Wolfenstein Edition 1, Edition 2, and then 2 other books, as I recall. So four total books. Were you surprised by the reception for Wolfenstein, and did that help you decide to go, write the book you actually wanted to write next, the Doom engine book? Is that how it sort of worked, or did you kind of take some time off, or how did that sort of progress to getting to, what we have here, the Doom Black Book here?
So I was surprised. Yes, I was super surprised by the reception. I did not expect 6 years later that people would still be talking about it. Wolfenstein was published in 2017, and the Doom one was in 2019. So it's been a few years. I was writing for myself, and even on my website, there is no tracker. There is no view counter, there is no command section, there is no analytics, because I think it's distracting. I just want to create something cool that I enjoy reading. And if I can come back a few years later and read the page that I wrote, I'm like, oh, okay, this is well written. I think that's what's the most important thing.
Yeah.
No, as per what I decided to write about, I think is wherever my curiosity takes me.
Yeah. So in writing the Doom book, how did that process start? I noticed you did have some articles on your website. Did it kind of evolve from some of your writings previously, and then you decided, well, I'm going to progress that into a book, or did you go back and read, Masters of Doom or some of these books and kind of try to tell the story from the development of the actual game? How did, what was the sort of starting point?
So I started, well, first of all, I really wanted to write about Doom because it was one of the turning points when I was a teenager. Like when I first saw it running, I was like blown away. And I didn't have a 486 at home. I had a 386. So I was enjoying 7 frames per second. But a neighbor, he had a 486 33 megahertz, and it was just a whole new world. So I think that was the real starting point, the fascination with this game. To write the book, actually, when I wrote the book, I understood that I knew very little about Doom. Because Doom, people talk about the binary space partition and the rendering and the diminished lighting, but there's so much more about it. There is like all the asset management, how you pack the data, how you, the memory manager, the sound controller, AI, you name it, the transition. It's very, very, very rich. So I started to just dig into the source code as where my curiosity took me. That was the driving point, the driving force. And it was really fun actually to open a source file, because there were 2 programmers on it, and you can instantly recognize who wrote what, because they have such a different programming style.
Interesting. So no code reviews back in that day and pushing to GitHub, and how are they developing? Do you know some of the stories about how they sort of developed their source code?
Oh, they have floppy disk. That's it. From what I understood, they had no source control. I think they started to have a source control for Quake 3.
Yeah.
Or maybe Quake.
I recall maybe Quake is when they had an FTP server at that point, but I think they were very frequently passing floppy disks, as you said. So that's just a nice antidote for students who are listening to this day. I mean, we don't have it that bad, I guess.
Okay, so yeah, I think in the case of id Software, things were kind of siloed, because John Romero will take care of working on tools. So you can keep that repository somewhere. John Carmack was working on the engine, and he was doing all that. And same thing for the artists who were doing the assets. So things were really siloed, and you just had to put it together. So I can understand why you don't really need version control to manage merging and stuff like that. Nowadays, it's of course completely impossible. But yeah, back in the days, the teams was small enough.
So I'll go ahead and what I'll say about this text is actually reading through this, as you said, Doom is known for things like the binary space partition, the inverse square root trick, some of these things.
No, I don't think they used it. I think they used it in Quake. In Quake 3.
In Quake? Okay, yeah. But what I will say about this, and you touched on this a bit, is some of the stuff like the asset management, things like compressing files together, and how that saves space on the file system. I would say this book is still a great book for anybody to read as a student who does game engine programming, to see how these components fit together, the assets, how an entity is structured. That stuff, in my mind, hasn't changed too much.
No. Something that hasn't changed at all with Doom is, and the way it's designed, is that you have a core writing in C, and the input and output are abstracted over something. There's a layer of abstraction, and any modern engine, any modern software does that as well. And that comes from the fact that they were developing on NextStation and they were running the game on PC. So the development process made them abstract everything. And yeah, to this day, I think it's still done the same.
Yeah, very cool, very cool. And then, so, at this point, you've written 3 books, Wolfenstein, the second edition, and Doom. And then you have the CP System book as well, which I know is also available generously on a PDF, but on your folks should buy it. What led you to CP System book?
It's the same idea. As a teenager, I played a lot of Street Fighter 2, and again, mesmerized by those huge character and the design of it, those beautiful colors, and it's an amazing video game. And it's even more amazing when you discover it from far away in an arcade, and you're like, wow, what are those people gathering around? And you look, you take a peek on the top of your those, and you're like, oh, this is beautiful. And yeah, you always wonder, how does it work? What do they do? What does an arcade have that my home computer doesn't to reach that graphic result? So yeah, you look under the hood and you're like, this is very interesting. There are actually 2 computers communicating over serial. They have their own RAM, their own ROM, and there is a graphic system. And then you understand that, and then you understand how MAME works, because everything is connected, right? So yeah, always the same story for all my 3 books.
So I think that's something that maybe folks who haven't been to our arcade as it was popular in the 80s and 90s may not understand how exciting it was to walk in an arcade and see the latest Street Fighter or Mortal Kombat or Cruisin' USA or whatever, and to see how much better those arcade systems, those cabinets, the graphics were. So
Every year it got better. Like after Street Fighter, I think the next big thing was Virtual Fighter. They moved to 3D. And then they moved to Tekken, which had textures. And then every year we got something amazing and new. And yeah, things have slowed down now.
Yeah, so it's changed a little bit to more console gaming and maybe different focus on mobile and VR, as we'll see here.
I think to some extent, I wonder if graphics have maxed out. Like, do we still need better graphics? I played a lot of Zelda, Breath of the Wild, and Tears of the Kingdom with my wife, and the graphics are not spectacular. It's just very, very pretty. But the real things about this game is the design, which is amazing. Like the interaction with elements, it's a lot of fun. It's well done. You explore things, you vibrate, you discover, and I'm not sure we still need to keep pushing the edge in the graphic world. Although I say that, and then every time I say something from Unreal with their procedurally generated landscape and the shadows, which it looks like they have finally managed to solve, I'm like, wow, this is really cool.
Yeah, it's interesting to hear you say that, because I've talked to a lot of folks who study graphics and are researchers, and then the folks who have moved away from the field onto other things and say, yeah, graphics has been dead for 15 years or longer even, they'll say. So it's a really interesting question, as you said, when you see some of these things. Are we done? When will we be done? Does it need to be done?
Yeah.
And I think
now it's going to be very interesting to see where things are being taken.
Yeah, I don't have an answer, but like you, I'm just enjoying the good stuff game developers are making regardless. So, going on this journey and thinking about the books you've written, and the process. Some of these books are multi-year efforts to do. They're projects of passion, certainly, as can be told. I mean, anybody who picks them up and reads them can tell that. Do you have another book in you? Is there something that you would want to do? Is there something that you're, as we found out, curious about, that you want to know how it works and be able to tell that story?
There are two books I'm thinking about. I wrote a bunch of articles about Another World, which was also a groundbreaking game. The design is amazing, and the way it looks, but also the internals. It's based on a virtual machine, and that's why it's been ported to everything. So I'm considering working on that. And the other one will be the Super Nintendo. Again, because it was such a groundbreaking video game console. It takes a lot of energy and courage to get into one. And the problem is that sometimes I find the energy, but I'm like, I write in 3. Maybe I should just go rock climbing or have a walk. And sometimes I'm like, if I wait long enough, maybe somebody else will write it and I can just buy it and read it, right? So, I mean, it's a bit of a paradox. It's that it's easier to write because I know the process, I have all the tools, but in a sense, I'm like, I have a harder time to get started. Maybe what I need is to rest a little bit and not force it. I think you, for those type of like multi-year project, you need to really enjoy the process. Getting there is certainly enjoyable, but you cannot sustain your effort if you don't enjoy it a little bit.
Yeah, well, we won't hold you to any promises, but if there is another book, I'll certainly be reading it. So
I also hope somebody is going to write the Quake book. I get an email almost every week about the game engine black book about Quake, and my answer is like, well, my collaboration kind of wrote it, but in reality, there is so much to cover that I would like to buy a book like this and just read it.
Yeah, my understanding is the Quake engine, especially the first one, was quite an endeavor to get up and running. So it would be interesting to hear about that journey.
Yes,
especially from the technical side, or from someone like Nabrash writing it. So great. So I want to give you a few sort of rapid fire questions here to kind of start wrapping things up a little bit, and then I'll give you the last word. But first I want to ask you, when's the last time you've played Doom or Wolfenstein or Street Fighter? Do you still play these games at all? Can you remember?
Street Fighter I played quite often with whoever I can find. When I got the Switch a few years ago, I bought myself like a huge like arcade controller and I played a lot. Doom, I think I played it a lot when I was writing the book, and something with Wolfenstein. I would say I probably play Doom once a year still. Yeah.
And it holds up. It's still fun.
It's I think it's as soon as you cross the threshold of 256 colors, like as soon as you enter the VGA realms, graphically it's like appealing enough that it has replay value if it's well designed. And obviously Doom is very well designed. A lot of PC games from the 90s and video games like the Super Nintendo or the Mega Drive, I think they are colorful enough to be still enjoyable. So I think those titles are going to live forever.
Yeah, agreed. So here's a hard one to throw at you, but favorite game of all time.
Oh my, well, Zelda: A Link to the Past. That's how I started to be interested in English, because I was trading games and the only way I could get Zelda was in English. And I was like, fine, I learn English, but it's just for this game because I'm never going to travel outside of France. So there's that aspect, and also the fact that up to the Super Nintendo, I had gained mostly on Amstrad CPC and Atari ST, so no hardware acceleration. And to enter the world of 50 frames per second, because French TV run at 50 frames per second, not 60. Beautiful colors and like all the time from Nintendo, it was just mind blowing. So yeah, Zelda. I would say I'm gonna allow myself to name 3, and it's gonna be Zelda, Doom, and Another World.
Perfect, perfect. And favorite game console?
Oh, Super Nintendo for sure.
I think we knew the answer coming here.
Yeah.
Um, and here's one. Just this is a selfish question for myself because I'm a teacher. But advice to young programmers. What would you tell them who are starting in the field?
Oh, that's a good one. I mean, can you recommend people to be passionate? I don't know, but I think to be really good at something, you need to have passion. If you go into a field just because, I don't know, people are pushing you there, or because the paycheck is substantial, or for any reason that is not liking it, I think it's going to be really hard. Because to be really good at anything, you need to spend a lot of time. And to spend a lot of time, the only thing is to be passionate about it. I don't know. Maybe as a teacher, you've seen students, the way they perform, and I think I would not be surprised if you were to tell me that the students who perform the best are the students who actually like it.
Absolutely. I think a lot of my students, like you, are the ones who have curiosity and they ask why, and they keep going a layer down and a layer down and a layer down. And as you said, being passionate and
Yeah,
curious.
asking why, being passionate. Two good advice.
Well, that's great advice. But so as we wrap up, again, I want to just thank you for your time. This has been a wonderful conversation. It's been something I've wanted to do for a long time. So to get a hold of you is a true honor on my end and a pleasure.
Thank you for having me. Thank you for having me. It's been
Yeah.
a pleasure.
And I just want to give you the last words if you want to say anything to end this conversation.
Oh, write documentation. It's very frustrating to get into a code base like I've done for Wolfenstein 3D and Doom, and you wonder why things happen. So if you put a little ASCII drawing next to your code, it would make people like me very happy.
Brilliant. I concur 100%. Well, thank you very much,
Thank you.
Fabien Sanglard, and yeah, thanks for your time here.
Thank you, Mike.